Everybody's asking about the running back cliff now after this season. What with 4 of the top running backs being over 28, talking about Aaron Jones.
Aaron Jones into the secondary, slashing his way past the 40 and taken down.
Alvin Kamara.
There's a lot of room. Alvin Kamara, room to roll.
James Conner.
Back to Conner, and Conner runs loose all the way down to around the 11-yard line.
Joe Mixon.
Once they get up there. Hand to Mixon, cut back. Joe Mixon, goodbye. Touchdown, Texans.
And who else are we missing?
Here goes Henry up a big running game. It's Dallas. Derrick Henry on the run. And William Lewis chasing at the 40, at the 30. He will score.
Everybody's still wondering how
Still rumbling. King Henry.
much is left in the tank.
And still going. And still going.
How long? Where is that cliff? Let's look to the data, use numbers, and do some analytics. I'm going to be getting the data from Pro Football Reference, beginning at 2006, going to 2020. There's just a lot of typing and looking, and so after all that, this is what the distribution looks like. Little histogram. There's a breakdown by age of every running back who got stats. Sort of looks like a normal distribution, but a little skewed. Majority is 24. That's the mean. Running back 1, 2, 3, still the same mean, 24. Does this mean running backs peak at 24? This distribution shows what ages running backs were drafted. So you can see up until age 25, there's continuously running backs being added into the league. In theory, we could just add the 21-year-olds drafted to the 22-year-olds drafted. And that's how many 22-year-olds are playing. We do that for all the ages. We begin to see the problem with that logic. Let's throw in that first distribution showing how many running backs are actually playing. So the green bar is the number of running backs drafted. The purple bar is the cumulative total that have been drafted. And the white bar is the amount of running backs who are in the league. It's this difference right here. That's what we're worried about. The number of running backs who fell off. Yellow bars represent the amount who are not in the NFL anymore. You can also put this in terms of percentage. The red bubbles are the purple bars divided by the white bars. It's the percentage of running backs still in the league. So here's the first takeaway. It's not a cliff so much as a gentle slope. There's clearly a linear trend here, so you can use regression to add in a lot of best fit. You can apply this function to some current running backs. Remember, this is the likelihood the running back is still in the league next year. And right away, it looks a little bit off. Here's the first problem. Let's use Derrick Henry. 30-year-old running back, still playing. He's in this group right here. This group, the yellow bar, is way bigger. These are the guys who didn't play when they were 30. So, Derrick Henry is already in pretty elite company as it is, just by still playing. One of maybe 20% of running backs. Need to apply some conditional probability here.
Bayes' theorem, or Bayes' rule, tells us that the probability of A given B is the probability of B given A times the probability of A, all divided by the probability of B.
What?
Let's unpack that. We're looking for the probability running back plays at 31, given he already played age 30. Difficult part using this formula is right here, at least for this one. How many 31-year-old players didn't play age 30? This number to me would be close to 100%, because most 31-year-old guys were still playing age 30. But let's just say 90%, just because. Probability of A is right here. Let's say about 23%. Probability of B right here, 26%. So 79%. 30-year-old has a 79% chance of playing when he's 31. But Derrick Henry was top 5 in rushing yards. Performance of the player is a big consideration. Along with age, production is significant also. Yeah, so here it is. X-axis points they already got. That's year 0. Next year points on the y-axis. And the graph looks good. Nice colors. The trends are good. You want to fit some regression lines? The awesome thing about this graph is it shows you two things at the same time with respect to age and performance. The lines of best fit relate points last year with points next year. It's putting a function to basically how many more points guy scores last year, the more points he's going to score this year. That's why the line goes up. You can also see how the line changes based on what age the player is. Here's a regression summary of 21 to 22, and 22 to 23, and so on. And we're recording these too, so. And 25 to 26. This is the next graph. Slopes and intercepts. Remember that last one? The new graph shows how those lines of best fit change. Formula is going to be different based on the age of the player. This is part of a multi-level approach. The first level is those lines 1 year to the next. The second level models how those lines change for age. The x-axis here is age. That's the predictor variable. And on this one, x-axis is fantasy points. And this is how we're modeling both things at the same time. Doing two things at once. And now we can put it all together.
Here is Henry.
Derrick Henry. We can estimate his points next year, starting with the second level, because you got to take your shoes off before you can take your socks off. This is just a linear equation. 2024 points, probably 300. Now let's dive into the math. Expecting 181 points from Derrick Henry, approximately. Let's try somebody else. How about Saquon Barkley? He is 27. You plug these numbers into the formula and 244. Notice the difference between these two formulas for a 30-year-old and a 27-year-old. These are the formulas we got from this graph. Remember, that's the second level. When you see them all together, there's a pattern. And now we bring out the first level. Points 1 year to points 1 year, points next. These lines of best fits, they're sort of all over the place. The second level is used to normalize these lines of best fit. Based on age, I mean. And that's the model right there. So let's put it to use. If you like the process, check out our website, www.fantasyforecast.com, where values are calculated the same way, correlating past performance with future performance. And if you get around to it, check out our podcast at FF Forecast, where we like to have a little bit more fun.
Mystery meat.
It's a mystery meat.
That's squirrel, though.
Like,
right?
it's definitely squirrel.
That's what you said. You
I mean,
said
it
you
kinda
wanted
might be.
I
squirrel.
googled squirrel, but
That doesn't look like a squirrel.
Yeah, I
you're
mean,
right.
I'll be honest.
Brought to you by Fantasy Forecast.